Welcome to lesson 4.5.1, and in this lesson we will be looking at sinusoidal graphs. State the amplitude and the period in both radians and degrees for each of the following functions. Y equals 5 sine of 3x.
So for this first question here, y equals 5 sine of 3x, okay, what we want to do here is we want to identify what the two pieces of information are that we're given here. We're given the 5 as the coefficient up front, and then we're given the 3 as the coefficient in the argument there. Now, think back to earlier in this course when we were talking about transformations. 5, okay, the number out front here is going to represent a vertical stretch. Now, think about what sine does. Okay, sine goes up to +1, down to -1, so it's got an amplitude of 1. So when we multiply that or stretch that vertically by a factor of 5, what we're going to get here is that our amplitude, okay, is going to be 5. Now, likewise, we can take a look at what's inside here. The 3, as the coefficient of the x there, the 3 is going to represent a horizontal stretch, but not by a factor of 3. It's going to represent a horizontal stretch by a factor of 1/3. Okay, so now think about what your period is supposed to be. Okay, the period is supposed to be 2 pi. Okay, but we are stretching it by a factor of 1/3. So this is going to be 2 pi divided by 3. Now that's what it's going to be in radians. Now what we got to do is we got to convert that into degrees, or actually what we could do is we could just think about it as if it was in degrees. Okay, or we could think of it like this. The period would just be 360, okay, divided by 3, or 120 degrees. So our amplitude is 5, and here's our period, neither radians or degrees.
Y equals -1/2 cosine of 1/3 x.
In this case right here, very similar to what we had just done. Okay, we're going to talk about this in terms of the transformations that we're seeing. But again, let's start with cosine. Cosine, just like sine, should start at 1 and go down to -1. Okay, not that sine starts at 1 here, but it fluctuates between a y value of 1 and a y value of -1. The amplitude of cosine is just 1. Out front here, we've got a vertical stretch by a factor of 1/2. Now, not -1/2. The negative is not part of the amplitude. The negative simply indicates a direction. Okay, it's just telling us that we're taking this cosine function and we're going to reflect it over the x-axis. But that has nothing to do with the amplitude. The amplitude is the separation, okay, or if you want to think of it like this way, it's half the distance from the top of the graph to the bottom of the graph. So in this case, the negative is really irrelevant. The amplitude is going to be the same as the vertical stretch. In this case, it's just going to be 1/2. Now, inside the function, okay, inside the argument here, we've got a 1/3 as the coefficient on the x there. That suggests that we've got a horizontal stretch by a factor of 3. Okay, so our period, normally our period would be 2 pi, but in this case we're stretching it by a factor of 3, or we're dividing by 1/3 is another way that I think a lot of people look at it this way. It doesn't really matter. You take a look at the b value here. The formula that we're working with is 2 pi over b, or multiply by the reciprocal, multiply this by 3, and you'll get 6 pi. Okay. The other way to think about it here is this could be in terms of degrees. This could be 360 divided by 1/3. And again, when you multiply by that reciprocal, bring that up, we'll get that the period is 1080 degrees.
State the amplitude and period in radians for each trigonometric function shown below.
So before we can identify the amplitude and the period here, and actually the period is actually going to be quite easy to read off of this, but what we're going to do here is we're going to identify what the maximum value is. Okay, and the maximum value that this function gets to is going to be 0.5. And the minimum value that the graph gets to is going to be down here at -0.5. Now, the reason why that's significant is because the amplitude is the max minus the min divided by 2. So this will be 0.5 minus -0.5 divided by 2. And when that's all said and done, the answer is 0.5, okay? Which is totally what I would have expected here, because the amplitude is half the distance from the bottom to the top, or it's the distance from the center of the graph to the top. And in this case, you can see, because of the symmetry here, that this thing is centered on the x-axis. So that distance right there was going to end up being the amplitude. Now, the period is a little bit easier here in this particular case, because I can see that what I'm looking at here is most easily described as a sine graph. It starts at the origin, passes through the origin, and its very first motion is to go up to its maximum, and then down to the middle here, down to the minimum, up to the middle here. So this is one full period, and it ends at 2 pi. The period is 2 pi. So in this case, just as we did with the previous question, we're going to start by identifying the maximum and minimum values here. The maximum value of this graph is 1. The minimum value of this graph is going to be -1. And so the amplitude, again, the amplitude is the max value minus the min value divided by 2. So this will be 1 minus -1 over 2. Or when all said and done, 1. And again, I can read that right off the graph if I really needed to, because I can see once again that this is symmetrically placed along the x-axis. Okay, the same amount above as there is below. And the amplitude is the distance from the center to the top, or the center to the bottom, if you want to think of it that way. Now, in this particular case here, the period is a little bit more difficult to read, because notice if I go from the top, like this now looks like a cosine graph to me, because it starts here on the y-axis. Starts at its maximum value. That's what a cosine graph would do. It drops down and then comes back up. This would be a full period, but I can't really read that clearly off of the graph. So another way that I can do this here is I'm going to kind of put a little mark right here. This is where I'm starting. I'm going to look for 2 pi. I mean, I recognize this as a sinusoidal graph, and so the period should be 2 pi unless it's been transformed. 2 pi is out here. Now, look at how many periods I've got. 1, 2, 3. There are 3 periods from 0 out to 2 pi, meaning that this period right here has got to be 1/3 of that distance. In other words, 2 pi divided by 3. That's probably the easiest way to approach it in a problem like this. This one right here looks very similar to the one that we just did, but this one's a little bit easier to read off. Once again, we'll take a look at the maximum and the minimum values first. So the maximum value is 2. The minimum value here is -2. And so amplitude is going to be max minus min over 2. So 2 minus -2 over 2, or just 2. Now, they're not always going to be evenly distributed or symmetrically distributed across the x-axis, but in this case they are. Now we're going to take a look at the period. And again, when I look at the y-axis here, I can see that the graph is starting at its maximum value. And if I just follow this along here, down all the way up to here, here's 1 period. But in this particular case, I can read off how far over that is. It's just pi over 2. And so the period is just pi over 2. Remember that a period consists of 4 distinct motions when we're talking about sinusoidal graphs. Over here, for the sine function that I saw here, there's the one motion goes up, and then down, down, and then up. It corresponds to the 4 quadrants. Quadrant 1, 2, 3, 4. Think about it. Sine is positive in 1 and 2, negative in 3 and 4. But there are 4 distinct motions. For the cosine graph, the 4 distinct motions, it starts at the top, goes down, and then down to the bottom. So it's positive in quadrant 1, negative quadrant 2, negative quadrant 3, positive quadrant 4. 4 distinct motions for a full period. The only reason I bring that up is because I know that sometimes people struggle to really see the period in these graphs. So for this particular graph right here, you kind of have to make an assumption, but it's a safe assumption, okay? It's an assumption that we want you to make when you see something like this. Notice that this really only looks like half of a period. Now, granted, I without seeing some of the other material here, I don't exactly know if that's exactly half of the period, but in this particular case here, that's a really good assumption here. So I start at the center, okay? I have to assume that the graph is symmetrically, okay, placed along the x-axis here, even though I have no evidence to that, okay, or at least to exactly corroborate that. But that's a good assumption here. So from the center, I go up My maximum value here is, what is that, 1.5? So as a result here, I can assume that the minimum value is negative 1.5, but I can't really see that. However, I know that this distance right here is my amplitude. And so my amplitude, I can say, is 1.5. Now, additionally, I'm assuming again that this is half of a period, and I can tell that this goes from 0 up to, when it hits the x-axis again here, it's out at 3 pi. Now, if that's only half the period, then I can assume that the other half comes down here, comes back up, is going to come over here. This will be an additional 3 pi, so that my total period here would be 6 pi. Okay? Now, just be aware that when you see something like that, I mean, that is a safe thing to just assume is true of this graph.
Write the equation of a sine function having an amplitude of 3/4 and a period of pi over 8.
Okay, so to write the equation here of the sine graph here, we're given information about the amplitude and the period here. So what we're going to do is kind of the reverse of what we did in question 1 of this assignment here. So what we got to do here is go from the amplitude to the vertical stretch. Now, I hope at this point here that you're comfortable with the fact that the amplitude is in fact the vertical stretch. So the a value here in our sinusoidal function is just going to be 3/4. The b value is a little bit different. Okay, the formula for this is going to be 2 pi divided by b. And then when I solve for b here, I get that b is going to equal 2 pi divided by the period. Now, sometimes I find that people aren't quite familiar with this little move to go from here to here. Just be aware that, for example, if I got to think of an example. Let's say we know that 3 is equal to 6 divided by 2, which is the same as 2 is equal to 6 divided by 3. I mean, I can swap those two, okay, and I maintain the equality here. So when I've got the period is equal to 2 pi divided by b, okay, because of that horizontal stretch, I can write that b is equal to 2 pi over the period. And in this case, that would be 2 pi divided by pi over 8, the period that we're given in the problem. Now here, I can cancel out the pi's, then because I'm dividing by an 8, that's like multiplying by 8, string this along, and I'm going to get 16. Okay, so now I'm going to write an equation here where the amplitude is 3/4, okay, and the b value is 16. So I would write that y is equal to 3/4 sine of 16x. That's the equation. Whoops, sorry. That's the equation that we're looking for here.
A cosine function having an amplitude of 2 and a period of 1080 degrees.
Okay, so in a similar sort of question here, this time with cosine. Once again, when I give you the amplitude, I am giving you what the vertical stretch is. So I'm telling you, when the amplitude is 2, that a value, the coefficient of the cosine function, is going to be 2. The more difficult piece, again, is going to be that period. But again, now in this case, sorry, I should say that we're in degrees. Okay, very specifically in degrees. So my formula for period would be 360 degrees divided by the b value, okay, because of the nature of that horizontal stretch. And again, because that's true, I can swap those two. And then 360 degrees over 1080 degrees, which is my period. And when I simplify that, I'll get 1/3. And actually, I would have known that from before because I believe that was in one of the previous questions there. So now I can write, therefore, okay, y is equal to 2 cosine of x over 3, or 1/3 x if you prefer to write it like that. I know that some people like to write the 1/3 out front here. It doesn't really matter. They're both saying the same thing.
Fill in the following chart.
All right, so in this question, we're going to identify the transformations really that we're seeing in these two equations here. And so what we're going to do is I'm going to do them both together, and we'll just work through this little chart here. So first of all, we're going to identify the amplitude of both of these. Now, remember that the amplitude is not affected by whether the initial coefficient here is positive or negative. Okay, so the first one here at -2, that means we've got a vertical stretch by a factor of 2. The negative is just throwing a reflection on here, so my amplitude is going to be 2. Here it's a little bit clearer. The vertical stretch is by a factor of 1/5, meaning my amplitude is going to be 1/5. In this particular case right here, to get the period, I need to know what my horizontal stretch is. And in this case here, this is a horizontal stretch by a factor of 3. Okay, B is equal to 1/3. Notice that I'm in degrees, so my period here is going to be 360 degrees divided by 1/3. And we've done that before actually, and that becomes 1080 degrees. Over here, my B value is 2. Okay, I can see that I'm in radians, and so my period is going to be 2 pi divided by 2, and in this case that's going to be just pi. Now let's take a look at the horizontal phase shift. And the horizontal phase shift, that's just a fancy name for horizontal translation. It's just as soon as you see it kind of worded like that, you know that we're dealing with trigonometry here. So now to get this, we need to separate out or make sure that the horizontal stretch has been factored away from the horizontal translation in order to clearly see this. Now, in this first question, that's not really an issue because it's going to be x plus 30 degrees. Okay, now, and I know I've discussed this before, but the way to understand which direction this is what would you do to get x by itself here? After you've brought everything over, the very last thing that you would do to get x by itself here would be to subtract that 30 degrees. And so this means, okay, that the translation here, the phase shift is going to be 30 degrees left. Okay, 30 degrees, I'm going to subtract 30 degrees. Now this is a little bit less obvious in this one because that horizontal stretch, okay, the B value has actually been distributed through. Notice that here the B value is separate from these two terms here. In this case it's been multiplied through. So what I need to do here is factor that out. And please, please be on the lookout for this, okay, because this is something that is going to happen. This is something they're totally going to test you on here. Make sure that you understand that you're looking for it here. So now that I've factored out that B value, I can see that my C value here, okay, is pi over 6. Now when I ask myself, what would I have to do to get x by itself here? Well, I'd have to add pi over 6 to both sides of the equation to get x by itself. That would be the very last thing I would do. And because of that, because I would be adding pi over 6, that would be pi over 6 to the right. Now, the vertical displacement is actually the probably one of the easier ones here because I'm just going to look at the value that's being added or subtracted on at the end of the equation here. This is plus 1, so this would mean 1 up. Over here, this is minus 4, so the vertical displacement here would be minus 4, or sorry, I shouldn't say minus 4. More accurately, I should say 4 down, to just give us a sense of what's going on here. Now, our mapping diagram is basically just illustrating what the image point is going to be. So the point x comma y in each of these is going to become what? Well, in this first case here, it's going to become 3x minus 30 degrees, comma, and this would become negative 2y plus 1. Now, the only thing that we haven't really discussed at this point here is that negative, but that negative is the result of the vertical reflection right here. In this next one here, this would become 1/2 x plus pi over 6, comma, 1/5 y minus, whoops, sorry, not minus 1, minus 4. And so that's the mapping. This is going to represent how every point on the original changes under the transformations indicated by the equation.
Assume the minimum possible phase shift. Write the equation in the form y equals a cosine of b x minus c plus d, and y equals a sine of b times x minus c plus d, where a is greater than 0 and where a is less than 0.
Okay, so question number 5 here, we've got a series of graphs, and what we're going to do here is we're going to come up with equations for them. Okay, 4 different equations. We're going to come with a positive sine, a negative sine, a positive cosine, and a negative cosine equation, because they all work. Okay, these are all considered sinusoidal graphs if they've got this kind of curve, and that could be either a sine function or a cosine function. Now, this is a really, I think, important skill. Once you're able to kind of look at the graph and come up with the equation, you've got a really strong understanding of the trigonometry that we're trying to get through here. So let's start with one. This one's actually relatively straightforward. Okay, probably one of the easier ones. What I'm going to do over here is I'm going to identify some of the more basic information that I can just read right off the graph. For example, I need to know, I need to know the maximum value of the graph, and I can read that off here, and it's going to be 3. Now I know it's maybe not entirely clear in the video, but in the workbook it should be a lot clearer. The minimum value is also fairly easy to read off. It's going to be -3. Okay, which means right off the bat I know that my A value, which is going to be my max minus my min over 2, will be 3 minus -3 over 2, or just 3. But I also know the D value, if you want to think of it like the median value, or the vertical displacement. Okay, I can figure that out. Now I can tell you right now, just by looking at this, that the answer is going to be 0. Okay, and I know that because the graph is symmetrically distributed over top of the x-axis. Okay, there's the same amount above as there is below, so the center of the graph is right here on the x-axis. But I've also got a formula for that. This is going to be the max plus the min divided by 2. It's the average of the max and the min. So this will be 3 plus -3 over 2. And 3 plus -3 is 0 divided by 2 is still just 0. So right now, I've got the A value and the D value. I've already got 50% of the equations that I need. And actually, these will be true regardless of whether I'm talking about sine or cosine. Now, let's take a look at the graph itself here. Now notice on the graph, on the y-axis here, that I'm going through the minimum, that intersects the graph at the minimum value. Now, that would suggest to me that the easiest, most natural way to interpret this is as a negative cosine graph. Okay? And we'll see that that actually is true, that is probably going to be the simplest of the 4 equations that we come up with here. But now to measure my period, all I got to do now is go and identify the 4 different motions of this graph. So 1 motion to the center, 1 motion to the top. So there's 2. 1 motion to the middle, 1 motion to the bottom. There's my 4 motions here. So here's where my period ends. And notice that it ends at pi. So my period here is going to be pi. Now that means that my B value is going to be 2 pi over the period. Period is pi, so 2 pi over pi, and the answer is 2. The B value here is going to be 2. And so now very, very quickly I've been able to identify 3 of the 4 different variables that I need to come up with the equations for the sine and cosine graphs for this graph that I'm looking at. Now, the next thing I'm going to do here is I'm going to start to label some points here, okay? Now, first of all, I'm going to draw a line through the D value. Okay, D was 0. I'm going to draw the line through. I'm just going to make that darker. And now what I'm going to do is I'm going to identify just a handful of points here, and you'll see what I'm doing in just a second. That's going to be A, B, C, D. Now notice where I'm picking these points here. E, F, G, H. What I'm doing is I'm grabbing key points here that are the maximum values or the minimum values or the middle values here, okay? The reason why I'm identifying those points is because those are the points that indicate what the horizontal translation is going to be for the given graphs here. So now I'm going to come over here and I'm going to start with positive sine. And in fact, what I'll do is I'm going to write out all 4 of the equations that I'm looking for here. So my positive sine is going to have a value of 3. So 3 sine of, I know that the B value is going to be 2. What I don't know is the horizontal phase shift. And I know that the D value is going to be 0. So this will be plus 0. Or it'll be -3 sine of 2. And again, I don't know what the horizontal phase shift would be for that. Or it's going to be 3 cosine 2. Don't know what the phase shift is. Or it's going to be -3 cosine 2, and I don't know what the phase shift is. So now let's take a look at sine. Sine should start like this. If you were to put a box around sine, on the left-hand side, it would start on the y-axis, but at the center of its motion. It starts on its median. So sine starts at the middle and goes up. So let's take a quick look here. Which of these variables that I put down here, these labels, which of these points would be a good starting point for a positive sine graph? Well, A would. A right here. There, it starts right on the middle and goes up as its first motion to its maximum and then down, down. A would be a good one. C wouldn't. C would be a good one for negative sign because it starts in the middle and goes down. D would also be a good starting point here. Now take a look at that. Between A and D, which one is closest to the y-axis? Because normally we want to use the minimum value. And the answer is D. Well, how far over is D? Well, it's maybe not completely obvious right off the bat here, but let's just take a quick look at it. Here's pi. Look at the grid. Look at the little markings on the grid. Starting at the y-axis, I've got 1, 2, 3, 4, 5, 6, 7, 8. There are 8 little squares to take me out to pi. That means each one of these little pies, each one of these little squares is pi over 8. And to get out to D is 2 of them. 2 pi over 8s. Well, that's pi over 4. Which means that this graph has been moved to the right pi over 4. That's the starting point. That's where D is. Now I take a look at negative sign. Negative sign, if you were to draw that little box around it, would start at the center and drop down. That would be a great starting point for sign, and we've already mentioned this. C would be an excellent one. Another good one here would be F. But which of these is going to be closer to the y-axis? Because I want the minimum value. And the answer is C. And just like D here, C is 2 of these little blocks over on the graph, which means that this is going to be negative pi over 8. Okay, negative pi over 4. This is a pi over 8. Here's another pi over 8. There's 2 of them. So that negative sign graph is going to be going to the left, pi over 4. Now we move to positive cosine. Positive cosine, if you were to draw a little box around it, would start at the top, drop down, and then go back up again. So we know that positive cosine is going to start up here. And when you look at this, the obvious points here would either be B or E. Now, here's the thing. Which of those is closer to the y-axis? Well, neither. They're both equally distant. So in this case here, you could use either one. And I suspect on an exam you'd be forced to choose one. Okay, they'd give you some information or some way of knowing which one to choose here. But in this case, that could be either direction here. And notice that in both cases, I'm going over. I can read this right off. It's pi over 2. So it's either to the left pi over 2 or to the right pi over 2. Okay, so either one of those would be correct. And now finally here, negative cosine would start at the bottom, go up, and then come back down again. So I'm looking for some values down here. It could be either D or G. D is closest to the y-axis. It's right on the y-axis. In fact, I wouldn't need to do anything to translate that. That's perfect. So what I might do here is really just bring in my parentheses here to illustrate that there hasn't been a horizontal translation. So there you go. So those are the 4 equations that we were looking for. Okay, this next graph here is a little bit more interesting just because it's a little bit offset. Most of the graphs that we've looked at this point have been kind of symmetrically placed along the x-axis. This one isn't. So finally a little bit of variation here. But we're going to approach it the exact same way. The first thing I'm going to do is identify the maximum value. You can read that off the graph. It's 7. The minimum value that we get to here looks to be -1. Okay, and so my A value is going to be the max minus the min. So I'm just going to start to do this now. Max minus the min over 2. And the answer in this case is going to be 4. 7 minus -1 is 8. Divided by 2 is 4. The D value is going to be the max plus the min divided by 2. 7 plus -1 is going to be 6. Divided by 2 is 3. Now, what I'm going to do right now, because I've just identified it, is I'm going to draw that horizontal line. I'm going to emphasize that horizontal line through where D is equal to 3, or the y-coordinate is equal to 3 there, okay, the median. The reason for that is because that's going to give me a way of identifying the horizontal translations here in just a few minutes. Okay, the next thing that I'm going to do here is figure out what the B value is, but first I'm going to look at my graph here and see if I can read off the period. Now, I like to typically start on the y-axis if I can. just because it's just a nice kind of anchor spot here. And when I read off a value, I know that I'm reading off the exact period in that case. And here it's actually quite simple. Notice that when I start on the y-axis here, I am starting at the middle, which indicates that this is probably most easily read as a sine graph. And because my first motion is to go down, this looks like it's going to be, and again, this is the easiest way to interpret this graph, as a negative sign. And the four motions are down, up, and then down, which takes me to here, and I can read right off that's 4 pi. My period is 4 pi. My b value will be 2 pi divided by the period, or 1/2. So there we go. So very quickly, I have 3/4 of all the information I need. So I can write this. Okay, this is going to be y is equal to 4 sine of 1/2, and what I don't know is the horizontal phase shift, but this will be plus 3. Or it's negative 4 sine of 1/2, don't know what the phase shift is, plus 3. Or 4 cosine of 1/2, whoops, figure out the phase shift in a second, plus 3. Or negative 4 cosine of 1/2 plus 3. So it's just the horizontal phase shift that I don't know specifically what it is in each of these cases here. So I'm going to come across here again, and I'm going to identify the key points. A, B, C, D, E, F, G, and I could identify this one down here, although, sorry, this one's starting to get kind of a distance away from the y-axis. That's probably not it. So, sine. Remember how sine works. It starts at the middle, goes up, down, and then up again. Now, when I say middle, I don't mean the x-axis. I mean on its middle, on its median. So it's going to start somewhere along this line, and it's going to go up. So it could either start at A or it could start at E. And now we've seen this before, a situation like this. These are evenly distributed, okay, on either side of C, the center there. So it could be either one. And like I said before, likely in a problem like this, if it was on an exam or a quiz, you'd be kind of nudged in the direction that you're supposed to go here. And I can read right off the graph how far over that is. It's going to be 2 pi. So this will work whether I go to the left or to the right, 2 pi radians. So here's one, or actually probably two variations of this equation for this particular graph here. Now, negative sign. A negative sign starts again on that center line, but it drops down first, goes up, and then comes back down again. So again, it's going to be one of these points here. It could either be C or G, because it's, again, starting at the middle and then goes down. But C is the one that's closest to the y-axis. In fact, it's on the y-axis. There is no phase shift necessary here. And so what I can do is really just bring this in. And that would be what that equation would look like. Now let's look at cosine. Positive cosine starts at the top, drops down, comes back up. So over here, it could either be B or F. But I'm looking for the one that's closest to the y-axis. So in this case, it's B. And I look down here, and actually this is really easy to read off. It's pi units to the left. So on my graph, to go pi units to the left, I would add pi. You got to remember how that works with those translations there. Okay, got to think back to that transformations chapter. And now finally, negative cosine would start at the bottom and come up, go down. And over here, it's either going to be D or H. And as I hinted at before, it really isn't going to be H, it's going to be D. And how far over is that? Well, it's a pi to the right. So that's going to be minus pi. And so those are the four possible equations that we're trying to get at with this particular graph. All right, last graph in this question here. And this one is probably the most complicated one. It's going to be the most difficult one here. But it's only difficult because it's got a minimum amount of information given to you. In fact, really, you could figure this out even if you take away the graph, just by identifying the maximum point and the minimum point. Those are really the only two bits of information that you need to figure out all of the possible equations for this. I'll show you here. But it isn't as straightforward as some of these other ones here, and you'll see why in just a second. But first of all, just like we did the previous ones, let's identify the max. And the maximum value here looks to be 9. The minimum value here looks to be -3. And so my A value will be the max minus the min over 2. So 9 minus -3 will be 12, divided by 2 is going to be 6. So the amplitude is going to be 6. The vertical displacement I'll find by doing evaluating the maximum plus the minimum divided by 2. 9 plus -3 is going to be 6, divided by 2 is 3. And then once again, what I'll do is I'm going to immediately draw a line through there at the median, at the middle. Again, that's going to help anchor me so that when I'm looking for the horizontal phase shift, I got some information here. I've got something visually to work with. Next thing I want to do is come up with my period. Now, this is not going to be as straightforward because I'm not even looking at a full period. I am, however, looking at half of a period. Okay? To go from the bottom to the middle to the top, those are 2 of the 4 motions that define any kind of a sinusoidal graph. And so because of that, from here to here represents half a period. Now let's just take a look at that. That's 5 pi over 4. This is -3 pi over 4. So my half of my period here, basically half of my period, is going to be 5 pi over 4 minus -3 pi over 4. Now, 5 pi over 4 minus, -3 pi over 4, that's going to be 8 pi over 4, okay, or 2 pi. But remember that this is supposed to be half of the period. Therefore, your period is equal to 4 pi. Okay? Period has to be 4 pi. So now I'll write that down here. B is going to be 2 pi divided by the period, okay, or 2 pi divided by 4 pi, or simplify that right down, 1/2. Okay, so that one took us a little bit more effort, but not that much more. And so that takes us to this point right here. We know y is going to equal, what was the amplitude here? 6 sine of 1/2 x. I don't know what the phase shift is. This is going to be +3. Or -6 sine of 1/2 x. Don't know what the phase shift is. +3. Y equals 6 cosine of 1/2 x. Don't know what the phase shift is. +3. Y equals -6 cosine 1/2 x. Don't know what the phase shift is. +3. So right away I can write all of that out. Okay, because I know 3/4 of every equation here. Now I'm going to come back and write in my points, label my points. Here's point A, B, C. Now here's, if it's not obvious at this point, let me clarify this. I need 4 equations here. I've only got 3 points that could be starting points. Something's not visible here. Okay, let's go through and see what that is. Sine starts at the middle and goes up, and then comes down and goes back up again. So starts along that middle line and goes up. Okay, so starts along the middle line, that's got to be B, and goes up. So B is the starting point here. I can read that off. That's pi over 4 units to the right, and I would write that in the equation as minus pi over 4. So there's my first equation. Negative sign starts at the middle and drops down first, and then goes up and comes back down. Not there. That's the one that's missing. Okay, so I got to figure out what's going on here. Well, the problem is I'm only focusing in on half the period here. This would drop down to here. This would come up to here. Okay, there would be 2 more points here that I could possibly use. So let's just label that. Let's label that D. We'll label this E. Bear in mind that it's a half period from B to D, from B to E. Now, think about this. Which one of these, D or E, is going to be closer to the y-axis? Well, if B was right on the y-axis, they would be evenly split, but everything's been moved to the right. Okay, B has been moved to the right, everything's been moved to the right, which means D moved closer to the y-axis, E moved further away. This is the one that I want. I got to figure out how far away D is from the y-axis. Let's think about that. B is right here at pi over 4, and D is a half period away. Well, I already calculated. We already know that a half period was 2 pi. So let's figure this out here. So for this particular question right here, pi over 4, if you subtract 2 pi from it, pi over 4 and subtract 2 pi, that's going to be pi over 4 minus 8 pi over 4, because I need common denominator there to do the subtraction. And then pi over 4 minus 8 over 4 is negative 7 pi over 4. Now what I've just done there is figure out where D is. D is over here at negative 7 pi over 4. Starting at B, which is pi over 4, I'm going to go backwards 2 pi. That's where negative sign starts, at 7 pi over 4, or 7 pi over 4 to the left. So I would write this as plus 7 pi over 4. That is by far the most difficult question you can get in this kind of a genre of questions. Okay. Yeah. So, and if you have to, just kind of go back over that, try to follow that through again. That is a tough one. These next two here we can read basically right off the graph here. Positive cosine, remember, starts at the top, drops back down, goes up. Well, the only point that matches that would be C. And C, if I read that off here, has been moved 5 pi over 4 to the right. So in my equation I would write negative 5 pi over 4. Negative cosine starts at the bottom, goes up, and then drops back down. And again, they're very easy to read that off. The only point that kind of matches that would be A. I can see that that's been, A is 3 pi over 4 to the left of the y-axis. So over here I would write this as positive 3 pi over 4. Okay, and there we go. There are the 4 equations that we are looking for. Not an easy question. Okay, but if you can go through, if you can do this one, man, you've really got that. Okay, you really shouldn't get stumped by too much that they can throw at you.
The graph of y equals cos of x is transformed as described. Determine the values of the parameters a, b, c, and d for the transformed function. Write the equation of the transformed function in the form y equals a cosine of b times x minus c plus d.
All right, well, the purpose of this question is really just to emphasize, if I can say it like that, to emphasize that trigonometry is no different than any other branch of mathematics when it comes to transformations here. So for example, other than I should say the vocabulary here, so we're talking about cosine here. A vertical stretch by a factor of 5 about the x-axis means the a value is going to be 5. A horizontal stretch by a factor of 3. Now, remember when you put a horizontal stretch in, you reciprocate it, so it's going to be 1/3. Translation of 1 unit to the left. Okay, well, 1 unit to the left. Now, bear in mind how this works. This means c is going to be -1. Now, I know people are going to say, well, wait a minute, shouldn't it be the opposite sign? And yeah, it will end up being the opposite sign. Remember that when you write the equation, there should be a subtraction in there, and that's what's going to happen. They're going to cancel. And a translation 10 units up means d is going to be equal to 10. And so my answer for this equation is going to be 5 cosine of 1/3 x minus -1, or x plus 1, plus 10. Okay, that's what we're looking for right here. And notice that I am going to separate the horizontal stretch from the translation here, from those two terms. I'm going to just write it factored out. Let's just jump right into the next one here. A vertical stretch by a factor of 1/5. In this case here, we know that a is therefore going to be 1/5. A horizontal stretch by a factor of 1/2. And again, when I put it into the equation, I need to reciprocate it. So this is going to end up being 2. Translation 7 to the right. So 7 to the right, and again, I know there are issues with signs here, but just work with me here. This is going to be positive. I want it to go to the right. and then 11 units down, d is going to be negative 11 here. So y will equal 1/5, there's my vertical stretch, cosine of 2, x, now remember it's subtraction inside here, so this is where my minus, and then I put my horizontal phase shift in, minus 7, close the parentheses on both of those, minus 11 to finish the equation. That's what we're looking for.
If the range of the function y equals a sine of b times x minus c is -5 out to 5, then determine the range of the new function y equals a sine of b times x minus c minus 2.
Okay, now here's another question that really probably fits more precisely in the chapter on transformations. However, we throw in a little bit of a trig twist on it, and it works just as well here. So we're told, without giving you too much detail about it here, that the range of this particular function is going to be -5 to 5. Okay. And so now, all we're going to do is we're going to translate it. Notice that all the pieces here are the same except for the vertical translation. We've dropped the whole thing down. So really, this is more a matter of understanding the concept, getting the idea here. So here's my trig function. Here's my range. It goes, you know, -5 here up to 5. What does this do to that? Well, it takes it and drops it down 2. The -5 drops down 2, the +5 drops down 2. And so my new range, okay, understanding that there's then a vertical displacement, okay, 2 down. So for my range now, my new range is going to be the set of y values, but it's going to go down to it's going to go down to -7 from -5. So -7 will be the minimum, up to 3, where y is once again an element of the reals. That's my new range.
A bylaw officer puts a mark on a tire at point N in the following diagram. The tire has a diameter of 60 centimeters and rotates at 12 revolutions per minute. After 3.75 seconds, the mark touches the ground for the first time. A. Determine the equation of the height of the mark as a function of time in the form h of t is equal to a sine of bt plus d, where a is greater than 0. And B. How far to the nearest tenth of a centimeter is the mark above the ground after 6.5 seconds?
Okay, the first thing to note when we start to make this transition into word problems here is that word problems, okay, word problems are in radians. Now, whether you like radians or not doesn't really matter. They're going to be in radians, okay? That's because there's that beautiful connection between angle measure and distance along the curve. Radians is just a far, far easier unit to be using in these kind of problems here. So anyway, here we go. Here's your tire. Bylaw officer puts a little mark on it. Now, we're given some information about the tire here. First of all, the tire has a diameter of 60 centimeters. Now, that bit of information right there is telling me something. Okay, if it's the diameter is 60, that means its radius is going to be 30. And the radius, okay, is the distance from the center to the top, distance from the center to the bottom, which automatically makes it the amplitude. So the amplitude immediately is 30. Bear in mind that I'm going to be looking for the equation here of the motion in just a second. Now it rotates, I know one other bit of information here. Because it's a tire, okay, because I can visualize this, I can see what's going on here, we assume that ground level is 0. Okay, the center of motion is going to be up here. It's going to pass through the center of the wheel. Now that's so important that you catch this. So often people mess this up. In fact, I've even got in my classroom where I teach, I've got a tire that's up on a stand just so that we can have a conversation about this, so people can kind of think about this. When you've got something rolling along the ground, that means the center of the wheel, the center of the motion, is the radius of the wheel above ground. Okay, so what this means really is that the vertical displacement is also 30 centimeters. Okay, it's not symmetrically placed along the x-axis or on ground level. It's been moved up so that the bottom of it is touching the x-axis. The other bit of information that you're given is this bit that it rotates at 12 revolutions per minute. Now, I've watched a lot of students get thrown off by what this means here. Okay, let's just think about this. I want to know what the period is of this motion. Now, this is, by the way, this is not moving very fast. But anyway, 12 revolutions per minute means the tire is going all the way around, okay, all the way around 12 times per minute. 12 times in a 60-second interval here. So let's just think of that. Okay, we've got our period, one period here. We want to know how much time it takes to go around once here. Well, in a 60-second interval, we've got 12 revolutions. And when we simplify that, we're going to get 5 seconds per revolution. That's my period. Okay, therefore that's my period. And so now I can figure out what my B value is. B is going to be 2 pi over the period, or 2 pi over 5. Now, don't get thrown off by this little bit of information here. It says after 3.75 seconds, the mark touches the ground for the first time. So in my diagram here, here's the mark. It goes up, comes down. Here's where it hits the ground here. There will be a lot of people out there that are going to be very tempted to think that 3.75 is the period. But notice, cut that off here, that that is not a full period. Boom, boom, boom. There are only 3 parts to the motion, and there should be 4. This is only 3/4 of the period here. That little number there, that's a red herring. Okay, that is meant to throw you off, just to see how carefully you're reading that. I know it's a little bit cruel here, but that's what that is. So now look at this. I've got 1, 2, 3 bits of information, okay? But look what the equation's asking for. It is only asking for those 3 bits. It is not specifically asking for the horizontal phase shift here. And you'll see in many cases, in many word problems, that's what they'll do. Okay, we already know that it is difficult enough to answer a word problem, let alone having to think about the horizontal phase shift. It may show up in a problem, but it may not. Okay, so I can simply write at this point here, therefore, that the height as a function of time is going to be 30 times the sine of 2 pi over 5 times time plus my vertical displacement of 30. So there's the equation that I'm looking for. Okay, and again, because, and we'll write it like this, because the wheel contacts the ground, and I mean that's what you'd expect. Okay, we're rolling along the ground. Because that's true, the A value is equivalent to the D value. Okay, now let's just jump ahead and we'll just finish this whole question here. Next one says, how far to the nearest tenth of a centimeter is the mark above the ground after 6.5 seconds? Well, I've got my function right here. Really all I'm asking you to do is to evaluate this at 6.5 seconds. So this becomes 30 times the sine of 2 pi over 5 times 6.5 plus 30. Now the trick is, remember, you have to be in radian mode when you enter that into your calculator, but it is just calculator work. And when you do that, let's just pull out the calculator here. Make sure that I am in radian mode. Okay, I am in radian mode. Let's go back. And so now this is going to become 30 times the sine of 2 pi divided by 5 times 6.5. Close their brackets, plus 30. And we're roughly 58.5 centimeters is what they're asking for.
The minimum depth of the tide, d meters t hours after midnight, can be approximated by the function d of t is equal to 10 plus 4 times the cosine of 0.5t, where t is between 0 and 24. A. Determine the maximum and minimum depths of the water. B. Determine the amount of time it takes the tide to come in and out. C. What is the depth of the water to the nearest tenth of a meter at 2 a.m.? And D. There is a boulder in the water that is 7.5 meters tall. At what time to the nearest minute does it break the surface of the water?
So now, for this question right here, the first question we're looking at is determine the maximum and minimum depths of the water. Now, normally when we would do this, we would know that the maximum value would be the D plus the absolute value of the A. and the minimum value would be the d value minus the absolute value of the a value here. Now that's still true, but where the issue arises here is when people look at this, oftentimes if you get locked into a way of thinking that's incorrect, it can become very hard to answer questions like this. This question is purposely written in an incorrect order, or not incorrect, I should say, but not a commonly organized way. In this case, the d value comes first because remember, d is the number, the value, or the vertical stretch that's added to the function at the end here. Now, this is just moved up front. This is the a value. This is the d value. So our maximum here is going to be 10 plus the absolute value of 4, okay, or 14. The minimum value here will be 10 minus the absolute value of a, okay, or 6. And so there's our maximum and our minimum depths here. Again, it's important to realize that this is our d, this is our a, and over here, this is our b. Okay, good. Now, the next question here says, determine the amount of time it takes for the tide to come in and out. In other words, what we're trying to do here is we want to figure out what the period of the function is. So the period of the function is determined by looking at the value of b. In this case, we know that b is going to equal 0.5. So our period will be 2 pi because we need to be in radians, over 0.5. Now, a bunch of you will realize, well, 2 pi over a half, dividing by a half is like multiplying by 2, so it's going to be 4 pi. And there's our period. Now, that is technically a correct answer, but that's not a good answer in this context. What you got to do is you got to put yourself on the shore. You know, a friend of yours comes up and says, hey, how long does it take the tide to come in and out? Well, if your answer is 4 pi, you're kind of a jerk. Okay, nobody talks like that. We want to convert that to its numeric value here, okay? So, but 4 pi as our period is basically equal, if you go to your calculator and plug that in, you're going to get 12.566 and so on. Okay, so how much time does that represent? Be careful with this. I've seen an awful lot of people say, oh, it's so easy, 12 hours and 56 or 57 minutes. No, that's not true at all. Okay, 12 hours, yes. Okay, but not 56 minutes. Time is not decimal. Okay, there aren't 100 minutes in an hour. There are 60. This is 0.566 or so of an hour. So what you need to do is you need to eliminate the 12 and just look at the decimal here. Multiply that decimal by 60, and what you'll get here is this is roughly going to be 12 hours and 34 minutes. Or if someone was standing on the shore and asked you, you might say 12 and a half hours. Okay, if that's what was going on there. Okay, next. Oops. What is the depth of the water in the harbor to the nearest meter, or the nearest tenth, at 2 a.m.? Okay, well that's just really just a matter of plugging this in. So we're going to evaluate the height, I'm using the wrong variable there. We're going to evaluate the depth when time is equivalent to 2. Okay, so that'll just be 4 really times the cosine of 0.5 times 2 plus 10. This is just calculator work, and the answer is roughly 12.2 meters when you round it. Okay? That's all that is. So in this case right here, again, we're just using the calculator, but you're just plugging the value in. In this case right here, this next one, this one's a little different. There is a boulder in the water that's 7.5 meters tall. At what time to the nearest meter does it break the surface of the water? So what we're interested in here is the moment when the height or the depth is 7.5 meters. This sort of question, the intention typically with the Alberta curriculum here is that you would do this one on your calculator. Now you can do it algebraically, okay, setting up the trigonometric equation, solving it. But typically this question is, the intention is that you're going to do it on your calculator. So first of all, we're going to make sure we're in radian mode, and I am. And now we're going to enter in our equation, which we know is 10 plus 4 cosine of 0.5x. Now, I am interested in where that y coordinate is equal to 7.5. So what I do is I put 7.5 in another y. Now I would graph this right away, but I'm going to adjust my window settings here. I already know that vertically that the graph fluctuates between 6 and 14 meters. So I'm going to give myself a little bit more room there. I'll say maybe, sorry, I'm dealing with the x first here. We already know that the period here, the t value is defined between 0 and 24, so I'm going to stick with that. Okay, so our window settings here, I'm going to make this 0 out to 24. I don't know, maybe have the hours go up by 2, so it doesn't really matter. So now what I was talking about before was the y min and max. The minimum that the function gets to is 6, so I'll give myself a little bit of room, make that 5. The maximum that it gets to was 14, so again, I'll give myself a little bit of room by making that 15. And now if I press graph, okay, there's the tide, so dropping down, up, down, goes back up again, and then here's that 7.5, and what I'm interested in here is where they intersect for the first time. I'm asking at what time does it break the water. So now we'll go second trace, and I'm looking for where these two graphs intersect. But now the cursor typically starts as close as it can to the middle of the screen on the first function, but I'll move that close to this point of intersection right here. It doesn't need to be right on it, just needs to be close to it. Press enter again to get past the guess, and boom. And so the time is 4.49 and so on. But remember, that's not a good answer. Okay, it's 4 o'clock in the morning. I can see that. Now I'm going to quit out of here. What's interesting about this is when I find a point of intersection, if I press X right now and press enter, the calculator remembered that point of intersection. So I got to try to tear this apart and figure out what it means. I know that the 4 that's out front here means 4 hours have passed after midnight. So this is 4 something. So what we're going to do, oh, my zoom is a little off here. Hold on. There we go. I'm going to subtract the 4 off of that and just be left with the decimal here. And then I'm going to multiply that by 60. So what we're getting here is that this happened at essentially 4 hours, and actually I might round that to the nearest minute. Okay, so this happened at roughly 4:30 in the morning, 4 hours and 30 minutes after midnight. Okay, now that's not exactly true. It's like looks more like 4 hours, 29 minutes, and like that's very close to 30 seconds, maybe slightly more, maybe 31 seconds here. Okay, but at this point here, that's probably as close as we really need it. Okay, but just remember when you're asking a question like this, try to avoid, unless the question's very specifically insisting on that decimal answer, try to answer the question the way a person would normally answer that question.
A Ferris wheel with a radius of 15 meters rotates once every 80 seconds. Passengers get on board at the point 2 meters above the ground at the bottom of the Ferris wheel. A. Write the equation to model the height of a passenger car on the Ferris wheel. Its height should be a function of time in the form y equals a cosine of bx plus d, where a is less than 0. And B. How soon after Emily gets on the Ferris wheel will she first reach a height of 28 meters?
All right, for this question right here, there's some information that we're going to yank out of it right away here. The Ferris wheel has a radius of 15 meters, and that tells us right away that the amplitude is going to be 15. Okay, because the radius of the wheel and the amplitude will be exactly the same. We're also told that it rotates once every 80 seconds. Now that is the period. Okay, so our period is 80 seconds. Now we don't typically need the period. What we need here is the b value. So we know that b is going to be 2 pi over the period, or 80. And so simplifying that as far as we can, that'll be pi over 40 is our value for the b variable. Okay. Now, passengers get on board at a point 2 meters above the ground at the bottom of the Ferris wheel. Okay, now the mistake that typically gets made here is people will jump on this and say, that means d is equal to 2. That's not true. Okay, if that were true, then the center of the wheel is going to be 2 meters above ground, but the amplitude of the wheel is 15. Meaning that as this thing rotates around, this is the spot right here where it crushed you into the pavement, drove you into the dirt, people died, it was terrible, oh, it was horrible. No. That 2 meters above the ground, that is where the bottom of the Ferris wheel is. Okay? The bottom of the Ferris wheel is 2 meters above the ground. And then the radius takes us from the bottom of the Ferris wheel to the center of the wheel. Now, in this case, that's 15, meaning that the center of motion, okay, the part where the motion is symmetrically distributed around, that is actually 17 meters above the ground here. So D is not equal to 2. Let's come over here and fix this. D is not equal to 2. D is equal to 17. So here are the three pieces that we needed for this problem. Notice that the phase shift is going to be 0. This is because we're being forced to make this a negative cosine graph. So it's going to start at the bottom and go up, and we don't need a phase shift for that. So we can jump right to the equation, making it negative 15, okay, cosine of pi over 40 times, x, yep, plus 17. Whoops. Plus 17. And so that's the equation that we're trying to build for this scenario here. Now the next question is, how soon after Emily gets on the Ferris wheel will she first reach the height of 28 meters? So this is a height, and I'm looking for the time here. This is very similar to the part of the question, the last part of the previous question. The intention here is that you're going to use your calculator to do it. So I'm going to go to our calculator here. First of all, we're going to make sure that we're in radian mode because this is a word problem. Then we're going to press y equals. And so now negative 15 cosine of pi divided by 40 times x plus 17. And we're looking for the first spot where we get to 28. Now before we jump into this, I got to adjust the window settings. I'm going to make my window 0 here, and we're going to go up to 80 because I know that the period of this thing is 80. So, and I'm just interested in the first time that it hits 28 meters here. So that should work out just fine there. In terms of height here, I know that the radius of the wheel is 15, so the diameter of the wheel is going to be 30, and it's been moved 2 units up. So off the ground here, maybe I'll let my y minimum be 0. And again, the diameter of the wheel is 30, but the bottom is 2 meters up, which means the top of the wheel is going to be up at 32. I'll maybe give myself 34, just to give myself a little bit of leeway here. And I don't know, maybe make this go up by 2s. I make my x scale go up by 5s, why not? Press graph, and so here's the motion from the bottom up and then down to the bottom, and here's 28. Okay, and so now, second trace to get into the calc menu. I'm looking for the intersect. We're going to move the cursor closer. First curve, second curve. Enter past the guess, and we get that happened at 36.5 seconds. Okay. Now in this particular case here, once we start talking about seconds here, now previous questions I would have taken here. Now we'll focus in on that number specifically. Here's the solution here. In previous questions, I would have taken that and converted that into a more appropriate time unit. But in this case, because we're talking specifically about seconds, it does actually make sense to just make this 30.5 seconds. That's about as, whoops, sorry, whoa, way over here. That's about as fine a line as we need to make.
The height h in meters above ground of a rider on a Ferris wheel as a function of time, t, in seconds, can be modeled by the sine function h of t is equal to 8 sine of pi over 60 times t minus 40 plus 11. A. Determine the maximum and minimum heights of the rider above the ground. B. Determine the time required for the Ferris wheel to complete one full revolution. And C. Determine the time to the nearest tenth of a second when the rider is at a height of 17 meters for the first time.
Okay, we're going to look at one more question here that's really going to be a bit repetitious, but I am going to do something a little different with the end here just to illustrate what you can do. So first of all, we're back on a Ferris wheel. Here's the equation that models our motion here. So the question is determine the maximum and minimum heights of the rider. Okay, well we know that the maximum is going to be the d value plus the absolute value of a, and the minimum value will be the d value minus the absolute value of a. And in this case, it's actually very straightforward to read. The d value is going to be 11, and the a value is 8. So this will be 11 plus the absolute value of 8, or 19. And this is going to be 11 minus the absolute value of 8, or 3. So the maximum height that we're going to get to is 19 meters, and the minimum height that we'll get to is is 3 meters. Okay. Now, the next question says determine the time required for the Ferris wheel to complete one full rotation. Well, that's the period. And period is going to be 2 pi divided by the b value. And we can just go up here and look at the b value. In this case here, it's a fraction of pi, which indicates to me that there's probably a really nice number that they're intending by that. So b in this case was pi over 60. The pi's will cancel here, and when you multiply by the reciprocal of that, the denominator here, we'll get 120. So the answer is the period of the rotation here is 120 seconds. It takes 2 minutes to go around. Okay. Now, the last question here says determine the time to the nearest tenth of a second when the rider is at 17 meters for the first time. Now, previously, we had answered this using the calculator, and that really is the expected way that you would approach this, but you don't need to. Okay, let me show you. So we're going to let height be 17, and our equation is 8 sine of pi over 60 t minus 40 plus 11. Okay, we actually have the skills to tear this apart and get the correct answer without having to use the calculator. What we got to do is we got to solve this trig equation for t. And that involves basically kind of tearing things apart, undoing stuff until we get into that t value. The first thing we're going to do here is there are 2 terms on the right hand side. We're going to move that 11 over first. And we'll get 6 is equal to 8 times the sine of pi over 60 t minus 40. Then, so our variable is locked within a trig function, so we're going to move that coefficient over to get it down to that. So I'll divide, and that'll give us 3/4 when I simplify that 6 over 8. Okay, whoops. And then this is going to be pi over 60 times t minus 40. Now, I have to solve this equation right here. Notice that the sine ratio is positive, and sine is positive in quadrants 1 and 2. Okay? So keep that in mind. We're going to come back to that in just a second. Now what I'm going to do is find the reference angle, and the reference angle, and now don't worry about what's inside here. Okay? That little bit of algebra that's inside the trigonometry, we will deal with that later. Okay, we're going to deal with the trig here first, the sine. So we're going to do the inverse sine of the absolute value of 3/4. Now the absolute value isn't really necessary here, but it's just a good habit to get into. And when we do this, bearing in mind that we're in radians, we're going to get approximately 0.848. Now, I've written that out to the thousandth, whatever. Okay, you're going to keep that number in your calculator anyway. Now, that, okay, is going to be our first quadrant answer. Our second quadrant answer, okay, think of it like this, our quad 1 is going to be 0.848 approximately. Our second quadrant angle is going to be pi minus that. And when you take pi minus that, you'll get roughly 2.294. So here are our 2 answers here. Now, that's not quite right yet, because all that has done is dealt with the trigonometry, okay? That's like 3/4 equals the sine of my thumb. Well, my thumb can equal either one of those 2. What we got to do now is we got to unpackage the algebra that's inside there. So, either pi over 60 times t minus 40 is equal to 0.848, okay? Or, I'll write it down here, pi over 60 times t minus 40 is equal to 2.294. Now, multiply through by 60, divide by pi, add 40, and we'll get t is equal to 56.2 roughly. Multiply by 60, divide by pi, add the 40, and we'll get that t is, see these are all approximate, is approximately 83.8. Okay, so in general, the solution to this problem is going to be t is equal to either 56.2 or 83.8 plus n times 120, okay, because remember we're adding the period, and we've already know that the period is 120, where n is an element of the integers, although making it integers doesn't really make much sense because you wouldn't go negatively, but that is a possibility. We are only interested in the first positive answer, and that ends up being just that 56.2. Therefore, t is equal to 56.2 seconds. So you can do it algebraically if you need to. You don't have to go to the calculator, but that is the expectation, and it is substantially quicker.